Welcome everybody back. Mr. Clark here. I just clearing up some notes there. I wanted to go over the break-even analysis since we're stuck with this online learning module instead of sitting in a classroom where we can ask questions and have a discussion. So, excuse me. So what I wanted to focus on is just a brief lesson on the break-even analysis. If you had the book checked out, it's 2-6, I think it's page 91, but we're talking about break-even analysis, and really we're saying if we make so much money and we spend a lot of money to make it, at what point are we going to cover all of our costs and be in the clear? So break-even analysis isn't how much profit we're making, how much it's costing us, it's the balance of both. We want that perfect balance between them. In our graph here we have them signified by these blue dots, break-even points. In a quadratic equation it would be like this whole equation equaled x, solve for x, and we'd have x1 and x2 as something. That would be our price point at which we can charge, and anywhere in there will be profit, but those are the extremes. That's the lowest and the highest price that we can charge. So on our graph, if we were to look at that, that would be down here is x1 and x2, and that's the point. Those are our limits where we're able to actually make profit. Anything less than the lower end or higher than the upper end is going to be a loss for us. Hugely important for businesses, especially small businesses, as they determine their cost of scale, or the economies of scale, excuse me, to doing business. The more you spend to make something, the more you need to make to cover those fixed costs, because those don't go away. We talked about variable plus fixed, and then we have our revenue, which is equal to price times the number that we sell. So however many that is, we have to determine what point we're making enough money to cover all of our bills so that everybody gets paid. I'll clear that out here. I need some space to work with. So going into that, I've got my graph here. That's all fine and dandy. I'm going to use an equation. Well, two equations. I already have them typed out into the calculator here. And so I have my first one, which is negative 3,500x plus 238,000. That would be an expense equation. As we change x, I'm saying x, it's actually price. As we change price, it's going to create more of a reduction in our overall expenses. Again, that's that going down this graph. Less people buying it. I'm not selling as much. And then if I look at the other function, we have negative 500x squared plus 30,000x. This is revenue. And this is calculated out to say, hey, as I increase my price, I'm going to make more money to a certain extent. Eventually, though, this value is going to drop out and we're not going to have any money coming in. We're going to be losing money. That's the break-even analysis piece in both those. So in a calculator, we would then graph those. So in my account, I went ahead and calculated these out ahead of time just to have them. Our A value in a quadratic, if you were to graph it, would be 500. Our B value will be negative 33,500. And our C value is going to be 238,000. Okay. Again, we can graph these, and if you have a calculator, we can just do those two equations and set them equal. Or we can solve to get a polynomial by itself. Oops, right. We can take this graph that we have here, and we can actually go into our menu feature, analyze the graph, and look for intersections between low and high, and there we go. We can continue this for the upper end as well. Low and high, doesn't matter where. It's telling us that we can sell for $58.9 or $8.08 and we'll break even. Now the neat thing about this, and same thing if you were to go to run out to Desmos and do the same thing, save yourself some time, right? Since you're going to be sitting on a computer at home instead of using a calculator in class, we can actually see the revenue piece as well. So we need to make $209,725 to cover our expenses at this point at $8.08, or we need to be making $31,774. Not as much, but our cost is much lower. The only challenge here in the graphing calculator is to determine your values. Technically, we don't need a negative x value because we're not going to be selling these, but notice the graph then is going to shift it anyway, so we want to go ahead and set that. And then if you're trying to get your graph on here to work out, all I did was change this whole thing. Here we go. And I just kept adding zeros until it shifted the graph up. So both of those work for us. That is the graphical way of solving this. The quadratic way is much simpler as well. The only thing is you might do this in parts. I'm going to run the whole thing through and calculate it out. I'm going to put a parenthesis up just because, and actually, there we go. It's a negative b, just because b happens to be a negative. And that's going to be minus or plus the square root. This is just me running into this equation here, all my information, square root of negative 33,500 minus 4 times a, which is 500, times c, which is 238,000, excuse me. Just one brief reminder, as you do this, you might want to make sure you put everything in parentheses if you're going to get some weird numbers, just because if you have negatives and you don't do them right and you mess up something in here with the parentheses, it can get really wonky, especially when you're squaring terms. Now we actually have to take this whole value. I was jumping the gun on it here. We have to take the whole value and we need to divide by 2a, which in our case is 1,000. When I enter that, alright, you'll notice I had a slight mistake in there because I thought I had enough parentheses. I didn't. So in this previous one, it was doing this plus this, which ended up doing the division first and then adding this. Not what we want. We have to do all the top first. So with that, I end up getting this now on the top, and that gave me the 58. The beautiful thing is now what we can do is just copy all this. We're going to paste it again, but change one thing, the negative sign. And that will give us the $8.08. So now between both of these methods, you can solve this. If you're working at home, I would honestly go here. So that's really the most difficult part of the whole lesson, is just finding where your range is so you can see the graph, or calculating the quadratic formula which solves for those values. And again, we have to simply just get it into the form of ax squared. I just realized you're not seeing that yet. There's our ax squared plus bx plus c equals 0, where that's your a value, b value, c value, and we're setting the whole thing equal to 0. Move that out of the way here a little bit. You know what? So that's really the bulk of what we're doing with this lesson. I hope that helps. If you have questions, please email me or ask me in Schoology. Whatever I can do to help, I want to help you out. I'm a teacher. That's my job. I can't imagine just sharing other people's videos. If you don't use this video, that's okay too. I won't be upset, but just know that it's another resource available for you while we're stuck here at home, instead of seeing each other's pretty faces in the classroom. Have a wonderful day. Look forward to more here in the next little bit.